Seafood, especially fish, has become an important component to the human diet. As the demand for fish rocketed, so did the problem of overfishing. In 2006, the journal Science predicted that by 2048, if we continue at the rate that we are fishing now, all the world's fisheries would collapse. The main cause of overfishing is due to the industrialized fishing techniques that have been developed in order to keep up with the increasing demands for fish. While these techniques are extremely efficient, meeting the demands of consumers, it may lead to detrimental effects, such as the endangerment of many species. Oftentimes, fish are caught before being able to reproduce. This leads to more fish being taken out of the ocean than there are being born, therefore causing the fish population to decline. The specific area that we chose to focus on was the northern Pacific Ocean, and the species that we will be focusing on are the Pacific bluefin tuna and the Chinook salmon.
The Pacific bluefin tuna and the Chinook salmon are both large fish that are prized for their delicious taste in Japanese cuisine. They are extremely high in demand, and people are continuously trying to sell and consume these fish. In the year 2013, the Pacific bluefin tuna population had dropped 96%, with more than 90% of the catch being young fish that haven't reproduced. Additionally, in 2018, the Chinook salmon who returned to the river once they reached adulthood, only 5% of the original population returned, meaning that the rest were fish in the ocean and didn't make it back.
Both the Pacific bluefin tuna and the Chinook salmon are crucial to the ecosystem and have large contributions towards maintaining the biodiversity of the hydrosphere where they reside in. These species are apex predators or tertiary consumers, which means that they prey on other species and have no predators. They also receive the least amount of energy from the transfer of energy in the ecosystem, which result in their population numbers being the least out of all species in the ecosystem. However, overfishing has become the ultimate predator to these apex predators. As large amounts of tuna and salmon are fished away, it puts the survival of these species at stake. The absence of apex predators can also lead to the imbalance of the ecosystem. For example, the Chinook salmon prey on carnivorous consumers like small schooling fish, which feed on herbivorous consumers like cockles, which feed on primary producers such as phytoplankton. With the absence of the Chinook salmon, their prey, the schooling fish, would increase in great amount as they have no predators. This leads to a decrease in cockles and an increase in phytoplankton. Eventually, the ecosystem will become imbalanced and would affect the biodiversity as species disappear. This is all due to the human activities like overfishing.
The solution that we found to overfishing is fish farming. Traditional fish farming requires fish to be kept in enclosed tanks or ponds, so instead of going out into the wild to fish salmon and tuna, the farmers would raise them instead, allowing the number of fish harvested to keep up with the demands without putting the number of wild fish at risk. The biggest benefit to fish farming is that it preserves the natural ecosystem that the salmon and tuna live in. The two fish that we chose are both apex predators, so them being gone in the wild means that their whole food chain will be in an imbalance and there would be an influx in smaller fish or other smaller organisms that aren't being eaten. If we stop fishing tuna and salmon out in the wild and their population stabilizes, that means the rest of the ecosystem will stabilize as well. Additionally, this would improve the economy of many coastal communities that rely on fish as their main income, since fish farming allows for year-round harvest as well as no restrictions on amount being harvested. It would also allow for more jobs as fish farming requires more staff than traditional fishing. The fish in fish farms are often also fed nutrient-enriched pellets that could end up making the fish larger or more nutritious than fish found in the wild. However, this solution does also create many problems that are still being resolved today. The first one being that since there are so many fish kept in so little space, the water can be extremely filthy and polluted. This allows for diseases to breed easier, and the close proximity of the fish to each other then allows the disease to spread extremely quickly. This then leads to the second problem, where although fish farming is protecting the natural ecosystem of the fish being farmed, it ends up hurting and contaminating the environment and ecosystem in the location of the fish farm. The first contaminant being fish that escape from the farm, especially if the fish is disease-ridden. Even those without diseases could still mess up a whole ecosystem if it disturbs the natural food chain. Other than escaped fish, polluted water filled with waste and uneaten food will run into nearby water or soil and harm the environment that way. Lastly, there is a problem with efficient energy transfer in fish farms. Large fish in fish farms such as salmon and tuna require almost 5 pounds of small fish in pellet form to support only 1 pound of salmon or tuna. This energy transfer is inefficient and requires a lot more harvest of smaller fish to keep up with the demands of the larger fish. The problems of traditional fish farming can be solved with a better solution: offshore fish farming methods like the aquapod. This is a better solution since the fish farming technique occurs far out into the ocean where it wouldn't impact any ecosystem, and the framework of the farm is built in a spherical shape which optimizes space and prevents fish from escaping. Additionally, the moving seawater and the optimization of space ensure that the fish would not contaminate each other. The biggest problem with this method is that it would cost more than both fishing and traditional fish farming. This would be the best fish farming solution that is closest to replicating wild fishing. Overall, there are many problems with traditional fish farming, arguably more problems and limitations than there are benefits. However, most of these problems could be solved by using open ocean fish farming. To popularize this technique more, there would need to be more development in the technology as well as finding ways to make it cheaper and more available to the public. Next time you go to a sushi restaurant, make sure to be aware of where your fish is coming from. Be aware of eating endangered species such as Pacific bluefin tuna and Chinook salmon, eating them only if they were harvested through sustainable fishing techniques.